In this video, I'd like to talk about the ML project for my team, which is face mask detection. Let me start off with the introduction. The COVID-19 pandemic has affected the world immensely and has brought about unprecedented changes in the world. In order to slow the spread of the virus, public health organizations all around the world are advocating the wearing of a mask, which prevents the virus from spreading. With the reopening of businesses and restaurants and other entities, it's becoming increasingly important to make sure that everyone who engages or enters any establishment is wearing a mask. For example, Uber has recently instituted a no mask, no ride policy, while other businesses are doing a manual check to make sure that customers are wearing a mask before they enter. As a new norm, it becomes imperative to perform face mask detection as a public health safety measure. Let me talk about the problem definition. This project aims to perform mask verification on full frontal faces. That is, given a photo of a face, we will be able to verify whether this person is wearing a mask or not. We will be using a dataset of 10,000 masked faces and 10,000 unmasked faces in grayscale, as is shown over here. I just want to make clear here that while there are many efforts to perform identity recognition given mask detection, our project primarily seeks to perform detection in order to assess whether a given person is wearing a mask or not. There are many applications where this would be useful, such as before you enter a grocery store or board a plane or enter a restaurant or enter a hospital, etc. Let me talk about the methods that we're using. We will prepare two balanced datasets and split them into a training and testing dataset. After creating the datasets, we will use a pre-trained model with the last classification layer removed to extract the features in the images. Then we will run the features through two different machine learning models, that is, binary classification and k-means clustering. We will evaluate the model using accuracy, F1 score, and other metrics. Given over here, I have a flowchart which shows the methods and the process that we're going to adopt. I'd also like to bring your attention to the pre-processing of data that we'll be doing. That is, we'll be converting the images into arrays, then we'll be labeling arrays for each image with a 0 for mask off and 1 for mask on, after which it's going to be ready for feature extraction. So what are the potential results? Based on existing literature and research, previous attempts at mask detection have reached over 90% accuracy. Our goal as a team is to reach a similar rate, but our initial goal is to reach 70% accuracy using binary classification. We are also interested in seeing how binary classification compares to the accuracy of a clustering approach. To discuss more the dataset that we have considered, we have found that the face mask detection dataset is ideal for us because it requires minimal pre-processing. The future scope is that our method can be extended to identify whether or not the mask is worn correctly and cluster data into more categories like mask, no mask, or incorrectly worn mask, etc. In the end, we have listed some of the references that we have used. Thank you for listening.